This is the first of our skill sharing series, which is a little mini schooling on various skills. It could be agricultural skills, food prep skills, technical skills like this, a variety of things. In September, we're going to have a couple of short workshops. One is on building a small bio stove, and the other is on welding. Welding skills based on the equipment we have at our other location, which is Grandview, which is about 2 miles up the road. That's our biochar facility, plus some agricultural and livestock. So my name is Richard Freudenberger. I'm the Energy and Resource Manager here, Coordinator here for Living Web Farms. So what I bring to the table is everything beyond the agricultural aspect of things. I'm not much of a farmer, I'm not even much of a gardener, but what I do is make sure that we incorporate as much energy saving and also alternative energy into the day-to-day operation here, not only on a daily basis, but especially going forward. Our vision is sort of entails a future that uses less petroleum, and we have to have alternatives for that. So we are, for example, you can see the 5.5 kilowatts of photovoltaic panels here. We've got another 5.5 down there at the other end of the farm. We've just finished installing a 42,000 BTU solar residential hot water solar thermal installation on one of the residences up here for the farm. 12 kilowatts of power up there for the hot water, it's the equivalent. And we have a wood-fired hydronic boiler which actually the wood heats water, which gets pumped through and contributes to the heating in these greenhouses here. And when it's going great, it burns fairly clean. We have developed a system wherein we're injecting biofuel into there like heating oil in the very beginning and the very end, so that cleans up the burn consistently. Doesn't use that much fuel because it's only in the beginning and the end, and it also will allow us, if we had to use that in lieu of wood. It's not as efficient, but it can be used in place of wood or to combine with the wood. So normally we have plenty of wood and we'll use the wood because it's a great renewable resource. It actually can be quite clean because it's combusting everything in it. So you get a cold day and a hot boiler and it just cranks. So that's only part of it. We've got a lot of other things going on for the future, including some composting toilet workshop we'll have in November, and there's a lot of ancillary stuff just here, keeping up with things here, just vetting things, making sure that a process or a product we buy here for the farm is contributing to the good betterment of the planet instead of against it, and also is made properly. Try to purchase from people that are responsible companies, and we always try to incorporate the resiliency and the sustainability into our stuff. So that's basically what we're doing. So this really came about as a tail end to the solar workshop we held here a couple of weeks ago after installing the solar thermal panels up there. And there's a lot of plumbing involved. Plumbing involves not only supply, like putting water through a pipe. It's not just feeding the water into your toilet or into your sink. It's also the whole encompassing picture of plumbing is also draining that water away and venting the pipes out the roof so that you don't have air traps and air bubbles, and the water flows freely without gurgling and all that stuff. We are not going to discuss those other two aspects of plumbing. This is totally a supply plumbing little workshop. It's just how to get water from where it's coming out of the well or from the city water line, and how to deal with repairs. I really want to tie in the solar part of it too, because that's important for people who are thinking about that. And then repairs choices. Maybe you're going to be building a house or replumbing a house, and how are you going to do that? What's there now? How can we either work with what you got or rip that out, and what's the best choice to put in new? Or how can we combine? There may be a lower floor that has a brand new PEX pipe like this and everything's great, but on the upstairs is old leaky copper or some type of unacceptable piping, and we want to get rid of that, and how are we going to join those two systems together and that kind of thing. So that's basically what I'm going to do here. We've got a lot of different kinds of pipe involved. The original piping, basically not from the Roman times, it was just lead, but the original piping for the most part was a black or a galvanized iron pipe, which normally it's used for gas piping. If you want to deliver gas to the house, it's a good solid, strong. It'll rust. It basically develops a coating of rust on the outside, and then it it rusts. It'll continue to rust, but it's very slowly. Once it's developed, it's outside. So they don't bother to paint it. It'll run. Oh, you'll see it a lot below the siding of the house, up on the concrete foundation. It'll sometimes be clipped along there, and you'll see it disappear into the house, and that's basically just gas pipe. But when it's galvanized, which I didn't have a piece of, but when it's galvanized, it is silvery in color, and that's a tin coating that stops the rust. So that's what they normally use for water pipe, because water's, it's going to be exposed, and you don't really want a bunch of rust in your water. So it's prepared that way. But this is a little bit problematic because it's threaded. I mean, when you buy it in raw lengths, it's not threaded. So you have to, a plumber, basically, when it comes in raw full lengths, which is either 10 or 20 feet, a plumber will have a machine. I mean, I have hand machines, which is really a lot of work, but they'll have an electric machine that's on a little legs, and they'll feed one end into it, and it'll cut the threads with oil, and then they have a male counterpart which actually cuts the inside of the threads, like a lot like that. You'll see it's just a male counterpart, and it just cuts the threads that way. So these will fit together and screw together. And we have to use either a pipe dope, which is a sealant, a thick liquid sealant, or we're going to have to use some special Teflon tape, which is much easier. Just wrap it around several times, and then once you get it on here, it'll tighten and seal. This is a tapered. You can see it, I guess, if you really look, but it's very minutely tapered at a very distinctive schedule. In other words, for every inch it tapers by a certain fraction of an inch. So the reason for that is, as you tighten whatever you're putting on there, it eventually gets so thick that it not only stops the thing from going closer, but it also tightens the leak, or tightens the fit so much that the leak can't happen. Even if you did not have the tape or the goop in there, the dope, or the sealant, I guess they call it, it would still leak over time. It may just find a way out, and it would drip. So we don't want it to do that either. Dripping. If it's under the house, you think, oh well, it's only a little drip. And that's not the attitude. That will not only waste water, but that will eventually turn into mildew, mold, a pool of water under the house. It eventually might even get into the foundation and the footings if it builds up too much. I mean, over years, a little drip can be buckets over years. So I personally have destroyed my kitchen subfloor because of a little hissy pinhole leak that I couldn't hear until somebody younger than me heard it and said, well, it's that, all this. And I spent a week arguing with her that it still wasn't anything until I actually went under there and saw it. And it just buckled it, just thickened the floor and just sort of buckled it and lifted the kitchen cabinets up by enough to make the doors funny. So I've got to get all that fixed now, just because I couldn't hear it. So essentially, any leakage is unacceptable. It has to be sealed. So that's what we started with. Most older homes, at some point, either have had or maybe even still have sections of iron pipe in their workings. Older homes will have 1/2 inch. This is a 3/4 inch pipe. And older homes might even have, especially smaller ones or single-story homes, may only have 1/2 inch pipe. The difference is that obviously a 3/4 inch pipe like this will let more water go through it, and the smaller the smaller the pipe, it's going to affect pressure. Going straight, it's not so much of a problem. Although in a really long straight run, there's friction every foot. Every foot of this pipe as the water goes through, has a little bit of friction. When you get 30 feet of it or 40 feet of it, it might go in with a nice pressure, 35, 40 pounds of pressure. It'll come out with maybe 20 pounds, which is not really good for your shower. It's not very comforting for your shower. What makes matters worse is when you have things like elbows and things like that. You've got to make corners, you've got to do this and then come back here and do that, and then you've got every one of these. The plumber will calculate, well, there's a loss of this much pressure for every one of those. So he counts all these up, and he counts how many feet of pipe he has, and he figures I start with 40, and if I'm going to end with 20, I'm going to have to go up a pipe size, probably, to get the kind of pressure you want at the end of the thing, at the end of the faucet or the shower. We don't really have to worry about that. I mean, we don't have time in the class to really go through all the calculations. Everything's online if you needed it. What we're going to be talking about is working with what you've already got and how we can replace with a better system, what you've already got, without having to redesign the whole thing. So, you know.
If you're replacing with a smaller pipe, back at the very beginning, does that mess up your regulator? Or
It's not going to mess up any regulation, it's just going to drop your pressure. If you had a small tap that you needed to run off, let's say you want to just wash the dog bowl in the laundry room or something like that, and you wanted to have just a little faucet that you didn't have a high expectation for, like, you know, like a big forceful hose to wash the dog, or something that you really needed a lot of water. Running a 1/2-inch line off of the 3/4 would be perfectly okay. You just expect less pressure and less water to come through. I wouldn't really see a reason other than expense, and it really isn't worth it. After all that work, it is not worth it to replace a 3/4-inch line through the whole house with a 1/2 inch, because, I mean, you know, it's a step down, not a step up. And on the other hand, if you're thinking about 1 inch, then you have to really look at, is it worth it? Am I going to get that much more delivery and pressure and all that, and spend that much more money? Because when you go from 3/4 to 1, that's quite a step up expense-wise. And you know, unless there's a really good reason for it, you know, most of the piping in the house is going to be either 1/2 or 3/4. So, you know, by and large, for the most applications, it's going to be a 3/4-inch pipe that you're going to be using. The other thing about using a bigger pipe, however, is that it'll take longer for your water, like you ask for hot water, especially if the hot water heater's, you know, where that tree is, and your kitchen's at this end of the house, and you turn that faucet on. If you had a 1/2-inch pipe, it might be 8 seconds before you get warm water. But if the bigger pipe, it might be 15 seconds or more, and you'd be waiting there. And that's, you know, every day you're doing that, that's a waste of water. And you can mitigate that. You can collect that water and use it elsewhere if you want to dedicate yourself to saving water, which I think we should be doing. But most people aren't going to be doing that. But you can flush your toilet with it. You can water the plants with it. You can drink it, certainly, but I mean, it's not cold. It's not going to be cold water. But you could use it put it in a jug and put it in your refrigerator and let it get cold. It doesn't taste any worse just because it's been in the hot water heater. It's not, you know, unless it's been sitting there for weeks, you know. So that's the only other thing practically to think about, is that a bigger pipe is going to pass more water before it gets hot. So after we had the iron pipe, the cat's meow in plumbing has been copper pipe. Copper is in, you know, higher quality houses. You'll see often in the real estate brochures, if you see, it'll say all copper plumbing or something like that. Copper is easier to work with. First of all, there's no threading or anything on it. No have to worry about that. It's lighter, so we don't have to have big, you know, you can just feel that. We got the same length essentially. You felt how heavy that other one was. So you've got, you know, when you've got 60 feet of piping under your house, either in the basement or under the crawl space, you've got to hang it from stuff. It gets to be heavy, and installation takes longer, and, you know, you got to think about that stuff. And repairs, you have to juggle around with stuff and all that. So the copper pipe is really a nice replacement. So the copper has its fittings too, and they're going to be elbows and T's like this, but they just essentially slip. It's a snug fit, goes on there, but they have to be soldered on there. And that's called a sweat solder. We're actually going to be doing that in a little bit. I'm just going to go through all the piping first. It takes a little bit of skill, but that all comes fairly rapidly. It's a quick learning curve once you've done a number of them. We had an intern here, he was here a few minutes ago, but he helped me on the solar stuff, and he pretty much got the hang of it after half a day I made him do it in places where if it was messed up, I could easily fix it, as opposed to a very difficult one. So I let him loose on a bunch of them. This requires a special kind of solder and a special kind of flux, which is actually a cleaning agent, and then a special kind of flame too. And there's a lot of other soldering that happens beyond plumbing soldering. I'll mention that, but all we're going to really talk about is plumbing soldering. You know, by the way, this all comes in like 3/8 inch, 1/2 inch, 3/4 inch, 1 inch, and then beyond that, it's really more commercial and industrial stuff. We don't have to worry about that. It gets expensive. A 10-foot length of, this isn't 10 feet, this is probably about 5.5 feet, maybe 6 feet. A 10-foot length of that's about $16, so that's not cheap. It didn't used to be that expensive, but copper is more rare. You know, it gets rarer every year. That's 3/4 inch. The 1/2 inch, I don't really know, it's probably somewhere in the $11 range, something like that. And these are all figured, if you're costing out your house, if you really want to go with a copper plumbing in your house, if you're doing a calculation, you really need to get the price, really make a comparison. And the fittings too, because they can really vary wildly. You'd think, well, if this 10 feet piece is $16, then this little teeny thing must be like 25 cents. Well, that's not. It's more expensive than half the pipe. I mean, they can be anywhere from $3.97 up to over $6 for weird shapes because they don't make as many of them, they don't sell as many of them. In the copper we have, as I said, we have different sizes. There's the 1/2 inch, it's a little skinnier. Often they'll use 1/2 inch for what they call risers, like the pipe that comes up from the main line up into your kitchen sink faucet or your bathroom sink, so it's a little skinnier, it doesn't need to have that much water. Shower will usually, but the hand washing sink isn't that important for flow. And the other thing is that not only are there different types of copper as far as rigid. This is rigid copper. It's a straight pipe. It doesn't really, bend that easily. And I mean, it's difficult to bend. This is actually a soft copper that comes in coils. Now this is sort of hard to bend because it's so big. It's so thick. But in smaller sizes like 1/2 inch and 3/8 and whatever, it doesn't take that much to bend it. The problem is, as you can see when we were doing it the other day with this piece, which is actually a scrap piece off the big cut. If you try to do it like that, or you don't use, there actually are tools to do it. If you don't use it properly, you'll put a kink in it. And I don't like that. That would be unacceptable if we had to put a fitting. There's no way we could fix that. We can't really hammer it. You can't really hammer it back into shape. Solder's not going to fill that. Even if I got it really good looking, it's still not going to, I wouldn't risk that. I'd come back and cut it here.
Is that a better potential to crack there, or
this kind of pipe, the bending?
no? Where
Oh yeah. I would cut that off completely. I'd come down here and just remove that whole piece and just start up here. But this will bend. It can. You see, I just bent it a little bit, and you can actually form it. I usually use electrical metallic tubing like this stuff. That's a whole different animal. That's not a plumbing pipe. That's a wire housing to make it safe from abrasion and bad stuff. The tool that bends that will work on this. It's just a half moon with a big handle on it, and you sort of latch it in there and just ease it up, and it'll walk the tubing right around that half moon and bend whatever you need to do.
Are these both just as potable?
Oh, everything's potable here. There's nothing that is not potable in this whole collection. Well, there is one little one there. I'll show you the difference. The other thing about copper pipe is there's 3 different thicknesses. So the wall thickness will change. There's a K, L, and M. The K is really thick wall. The L is a standard thick wall, and then the M is a lightweight wall. In this area in the mountains here, where we live, and a lot of places in the country where the water is really hard with minerals, it will eat through the copper over time, just the hardness of the water. So I wouldn't ever even use M for anything other than, say, decorative chandeliers out of copper, or might do some art. That's fine. And that's actually easier to bend because the wall thickness is smaller. I would stick with the middle, the L pipe. It has a thicker wall. The K is not something, you can't buy the K at Lowe's. I mean, it's not, that's more of a professional plumber's order. And you can get it. I mean, you can go down to Hajoka or something, or some plumber supply and get it. But I don't think it's necessary to go that far because it's expensive. It's a lot thicker inside. So we just live with the L pipe, and my water heater, it does develop a pinhole leak every maybe 6 years or so. And I just cut it out and put a new piece in. This will handle temperatures of 400 degrees. I mean, it's not, your water heater shouldn't really be running at more than 120 degrees. But like in a solar system, it is possible to get that plumbing to 300 degrees in the solar system. It's an extremely lively and hot way to heat water. We're actually making too much water at this point. It only works a couple hours a day, and it shuts itself down because it's too hot. That'll change in the winter, of course, but the copper pipe is the only thing that can really handle the heat. Well, the copper and the iron. We don't even really deal with iron anymore. I wouldn't really use the iron unless you wanted to recreate the original plumbing for some reason, a historical value or something. So this will handle the heat, and the closer to the heat source, the hot water is, that's where the leak is going to happen. So if my water tank's here and I'm developing hot water and pushing it up through and sending it out the, out the pipe into your shower, the leaks are going to be within this first foot normally.
Is that because of the heat, or?
Yeah, the heat encourages the erosion of the inside of the pipe. So obviously the hottest part of the path is going to be close to the water heater. So this is where it's going to happen. And I've done this. I have cut out the leaky pipe, and because I didn't have a piece of, it's a weekend, I didn't want to go to town, and I cut, snip, and put a piece of this in, okay, which works fine. Except now, the leak doesn't happen in that. It's going to come up here and do it. So I keep on doing that, and it's going to finally it's in the house, and it's going to start leaking where I really don't want to work on it. So it's better to just sacrifice. That's what I call it, a sacrificial, piece of copper, because it can handle the heat. And if it leaks, I can fix it because it's right in front of me. It's out in the garage. I have a water heater in the garage, and I can just deal with it. So, I immediately know, because either the cat starts screaming or when there's a leak, because it's water on the floor and he doesn't like to walk in the water. So, it's, I go out there. And like I said, it's only every 6 years or so. It's sort of like clockwork. So we have the 3 different thicknesses of pipe, and we also have the soft tubing. They actually call it tubing, even though it's thick like a pipe, and rigid pipe. And they're both the same outside diameter, which actually makes a difference, as I will explain. In the next transition, which I do not have a piece of because it's very difficult to get anymore, I could cut one from the house we worked on a couple weeks ago, but I don't want to make a leak over there. So it's called polybutylene piping. It's a gray pipe that was very common. It was supposed to be the answer to our plumbing woes in the 90s. Actually, it started in the late 80s. In the 90s, people used a lot of it, especially in manufactured homes, mobile homes, prefab type homes where where sort of like they kitted things together in a factory. The polybutylene pipe, which is called PB, is a gray pipe. It looks a lot like this. It's flexible. It's gray though. It's gray in color, and it's easy to work with. It's easy to cut. It's easy to join. Everything's good about it, except for some reason the manufacturer and the inventor never tested it in the presence of chlorine. So that in city water, because we don't have chlorine in our wells, but in city water, which is like most of the population, over time those things develop splits, holes, leaks, litigious legal issues. I mean, it was just, lawsuits, Canada and the U.S. Houses still use it. I mean, the reason it still works up there is because we don't have any chlorine in the water, and that's
plastic or type of metal.
What's that?
The polybutylene.
It's plastic. It's polybutylene is a one form of, there's polyethylene, there's polyvinyl chloride, there's polybutylene. So anything with poly is plastic. It's just a chemically altered plastic which has good qualities, like it bends and all this stuff. So it makes it really easy to work with. It makes it easy to cut. But unfortunately, they just didn't do their homework. So the next step was PEX, which is cross-linked polyethylene. PE is polyethylene, X is cross-linked. Cross-linked means that the molecular structure inside this plastic is actually reinforced in its molecular structure. So this stuff's really pretty neat. And I don't, people have said that, okay, in 10 more years, PEX is going to be the new polybutylene, but I don't believe that. I don't see that. We've had a lot of years now with this stuff, and it's again, it's easy to work with. It has a higher temperature. It's a 180-degree temperature limit, which is really nice. You don't really need to be running that hot water through your house anyway. It cuts easy. It fits easy, clamps together easily. It's not freeze-proof, but it will tolerate some degree of freezing because it can actually swell without breaking. So it's not like copper will not tolerate any. It splits a huge rip down the side. This is an example of a real piece of work, actually. This is actually my first hot water heater removal. I put in a hydronic heating system for the house, which is a boiler, and it runs hot water through the house instead of forcing air. And that made hot water. But when the heat exchanger to that boiler broke, I didn't want to spend $800, so I just bought a new water heater, like an electric water heater, and put this thing in. That was the first invocation of it. That actually split or poked from the erosion of the high mineral water. I think this time I was going someplace and I just said, I'm just going to take some duct tape and wrap it around there. And that's obviously not a solution, so the next day I had to fix it. But just to keep the water from squirting all over the place, I just did that. But this is a good example of several different kinds of piping. You've got, you've got copper here, you've got a union, which actually is a good little way to allow you to remove an appliance like a water heater without having to resolder everything. It's a good seal. They're a little expensive. It might be $6. You only need 2 of them. But you have this on the water heater and this on the rest of your plumbing, and you cut them and measure them so that you can actually unscrew and rescrew. It has a very nice little curved seat, and the inside of this is a very nice little curved matching seat. And so when that gets in there, if I held it, it wouldn't be good enough. You can actually see it. I mean, it's all nasty, but you can look at it.
Would you flare your own pipe?
Do I flare it? Not on this stuff. It's already pre-done. I have some flaring down in the shed, which I forgot to get, and I will bring that up. Yeah, it just fits like that, and then you screw that big knuckle onto the thing, and it puts it on there.
Can I ask you, there's red and blue
Yes,
packs.
and white too.
And is there a difference in the pipe itself, or is it just to...
It's really just color coding because it's nice. It's nice for plumbers to see what's the cold water line. Cold is blue and red's hot. They won't always do that. I mean, they won't always color code it, and they might not always have. They're not going to run back to the shop and get another big roll of blue just to finish the little 3 feet they need. In fact, when I was just too busy to replumb underneath the house, we actually hired a plumber, and he came with a bid, and I said, that's just out of the. Well, his helper came, his assistant came with the bid, and I said, that's just, I can't do that, And he said, let me just revisit that. The owner came by, and he said, if you don't mind me, he goes, I've got 10-foot scraps and 20-foot scraps and 2-foot scraps. He goes, if you don't care what color everything is, he goes, I'll just cut that price down to about half. Yeah. So we just, we really cut it back, and I didn't care. So, and he said, I'm training a guy too, so if you don't mind us being there longer and all that, he goes, I'll make it worth it. So, the color doesn't matter. There is other stuff that does matter, which I'll explain to you, sort of the look of it, but, I'll be there in a second. This is the other part. This is a joint between an old copper pipe and a new PEX. This is a white PEX pipe, but a new PEX pipe, there's a barbed fitting in here. You can't see it here, but I'll show you what it looks like. That part there is brass and it's smooth on the inside, so we can solder that onto the copper. But this end has a barb just like that, and it has sort of a sharp, it'll go on easy, but it has a sharp edge, so it doesn't really want to come off easy. And then we put a copper ring on there, and we put the pipe over, and then we use a special tool, which we'll do over here in a minute, to mush that in there. And the way the tool's designed, it puts equal pressure all around. And don't ask me how it does it, but it's you have to adjust it once in a while. It's very meticulous about it. And it is basically, unless you make an egregious error and put it crooked or you don't pay attention, it doesn't leak. I mean, it just never does. You can't turn it. I don't care. You can't turn it, but sometimes you wish you were able to turn it because you said, oh, I wish that thing would pull up a little bit, so I don't have to push it up there. But it'll not turn, but it'll not leak either. The PEX comes in white, which is pretty common, just the white, what you saw here. And then it'll come in red for the hot water, and then blue for the cold water. But it doesn't matter. It doesn't make any difference. It's clearly marked on the side. It'll say temperature ratings, 3/4 inch. It depends on what section you cut out because it just repeats itself. But it'll say potable water. That's important if you're going to put it for that. It comes like this. I mean, unless you go to Lowe's and get sticks, which is not economical. And Lowe's sells it like this too, but I usually get it for the plumbing supply, not Lowe's. Not just for the fact the plumbing supplies has everything, and Lowe's or Home Depot can be out of stuff. But if you just need a little valve or a little fixing something, their big box stores are fine. Yeah.
This is the newest piping available?
There are a number of other variants on the PEX that are mainly in commercial industrial use, and I'm not even going to talk about them.
Is this the same as SharkBite?
The SharkBite, I have SharkBite products. It's not the same as SharkBite, but it fits a SharkBite. And I'll explain that because that really is an easy way. It's an expensive way, but it's an easy way to fix stuff without having to worry about clamps or anything. It's flexible. So it comes in a roll. It's 100 feet right there.
You say the blue and the red, it really doesn't matter. If you're going to put hot water in the blue, it's fine.
Yeah, it's fine. The temperature ratings will be on the side of the, if you're questioning it, it'll be written on the side. If you get a long enough piece, you can just look. So potable water, 180 degrees. Now, as pressure increases, that temperature limit will decrease. But you're not going to be running 180 degree water through, or you shouldn't be. Except, in this case, in my heating system at home, and anybody else's, it's called hydronic heating or hydro water heating. So radiant floor heating is actually where you put tubes underneath the ground. They'll use a PEX pipe there too, but that's not as hot. That's a low grade heat, so that's maximum about 120 degrees, because once you get hotter than 120, it'll actually spall and crack the concrete, and you don't want that. That just oozes heat out really gently, and it's just a really nice heat. My heat in my house, because I couldn't put, I have a wooden joisted floor, and I didn't want to pour a special layer of gypsum concrete to hide the tubing. I just put in perimeter baseboard heating, like you see in a church, maybe a church or some of the maybe commercial buildings, or they're just little white, usually white or gray, baseboard mounted radiators. Basically, they're just little skinny things, and in there's copper pipe, a straight piece of copper pipe with fins very close together. Fins are about 2 by 2, and they're all stacked very, very close. So as the hot water goes through, it just radiates heat out of those fins, and the top of the housing has a crack, and the bottom of the housing has a crack. So the air just goes up the wall, ceiling, and then it gets cool. By that time it's cooler. It falls down, moves along the floor. Even though there's no fan, there's no motor, there's nothing like that. It just makes a convecular motion. Totally quiet, really nice heat. It's not dripping moist, but it's like old-fashioned radiator heat, and it's a really nice heating system. But it's not as cheap as forced air. So in my house, I run my hot water through the radiators at 165 to 180 degrees. Then we have this stuff. It's not potable. It's a PVC with an oxygen barrier in it. It's a special kind of a heating pipe. It's a hydronic heating, and you can look at it. The only way to identify it, really, other than reading the label, is it's very shiny. You can always tell by the shininess of it.
So the oxygen barrier prevents airlocks?
It prevents air from getting into it. The only real reason for that is that the pumps you use to circulate the water through is usually iron, and once you start introducing a lot of oxygen to the water, the iron pumps will fail prematurely. So either you buy a very expensive brass pump, or you use that kind of pipe, so you introduce very little air into it, and so
So on your solar hot water, you had solar hot water going to your tank or whatever.
Yeah.
And then you would use this coming out of it?
The loop from the solar collectors down to the storage tank and back up again, always it has to be copper. Now, some code jurisdictions allow you to use PEX 15 feet from the connection with the solar collector. Even though it's allowed, I would never do that. Like I said, that water can get extremely hot, and this will melt. I mean, if it gets too hot, it will melt. Some solar systems like ours are more fail-safe, where they actually drain back. So if there's no water to get hot. The water just drains into a tank, takes it away from the sun, and it'll cool down. And then it gets pumped up again, and when it gets cool at a certain temperature, it gets pumped up and starts it all over again. Many solar systems, what they call glycol loops, which have a little bit of antifreeze in it, and that gets constantly circulated, and that can get, especially if a part fails, which can happen, a vent or a valve or something fails, or a sensor, it'll just keep on circulating and get really hot, and it can melt the PEX. So what we do is we take it from the storage tank, then we use the PEX, because at that point, actually the code requires, and even though a lot of do-it-yourselfers don't do it, but in this particular case I would recommend it. The code requires that you have what they call a mixing valve, so that when the hot water comes out of the tank, if it gets higher than 160 degrees, cold water, it senses this, and cold water is sent, you plumb in a cold water line, so it allows cold water to be introduced into your water going to the house, so that it can't get any hotter than 160. And you can adjust that between 110 and 160. So, in my mind, I'm saying, well, what's the point of spending all that money to heat water, and then you're just throwing cold water into it? But it's just a safety factor, because you can really scald yourself in the shower if you're not expecting it. So that's a safety factor, and so the water going from the tank through the house is not going to get any higher than, 100. I wouldn't even set it for 160. I mean, it'd probably be better, say 140 or something like that, so it's not going to really hurt. So, we look for that kind of piping. It's non-potable. It's going to be a shiny surface. And, if you were buying that, you can't get that at Lowe's or Home Depot. You may be able to order it, but that would be something you have to get from a plumbing supply house like a Joka or Ferguson or some of those places like that. One thing I didn't mention, because it's PVC again, this is what they call CPVC. And the difference is the color. I mean, this is more of a white, like that, and this is more of a beige. And the difference in the actual physical function of it is that this stuff, this particular stuff is flexible too, but this is a smaller size. I mean, I didn't happen to have one, the 3/4 inch one, so I had this little one. It's 1/2 inch. CPVC is a high temperature PVC, so they use this for hot water lines, and you can use it for cold water line too. But generally, because it's a little more expensive, they would use PVC on the cold and CPVC on the hot. So with PEX, we really, PVC is not, unless you're delivering water, like they still use it a lot for, if you had a cistern up here and you're sending 100 feet, because it's so cheap, you're sending 120 feet of water down to the faucet down here or something, then we might use that and bury it, of course. This does not take UV rays very well. I mean, you can paint it, but this doesn't like ultraviolet rays from the sun. That doesn't like ultraviolet rays. That doesn't like ultraviolet rays. That doesn't like ultraviolet. That doesn't like ultraviolet. The only ones that can stand it is copper and iron. So other than painting it, which is sort of a lost cause anyway, because it'll come off, you really don't want to expose that to open sunlight. So they have to be buried. For freezing, this will freeze and crack. So will the PVC.